Hey friends, my name is C and welcome back to a new video for IGCSE Geography, and today we have 2.3 for coast for theme 2 of the natural environment. So here's a specification from the IGCSE Geography website, and here's a case study that I'll be looking into, which is the opportunities presented by an area of coastline, and we'll look into the Holderness Coastline. Starting with marine processes. So these processes are similar to the river processes that we saw in the last video. So we have the marine erosion and marine transport, where marine erosion includes these four processes, which are abrasion or corrosion, which is when the rocks or the lodes grind along the seabank or bed, which wears it away. As well as attrition, where basically two lodes or two rocks knock against each other. So let's say this is a rock and this is a rock. They hit against each other, which result in small bits falling off. Which results in small bits falling off, and that's attrition. And then we have hydraulic action, which is when the force of air and water on the cracks on the sides of the cliff, causing the cracks to increase in pressure and explode. So what this means is that, let's say you have a cliff right here with a crack like this, right? And let's say you have the water over here, water, like the water right here, right? Water. So there'll be time where the tide is high, so the water will be forced into the crack, which basically increases the pressure inside the crack, which forces it to explode due to the high pressure, which causes it to crack, and this is called hydraulic action. And then we have solution or corrosion, which is when the seawater reacts chemically, so it's quite important, chemically, with the loads and the minerals they contain and dissolves them. And marine transport, here are the 5 marine transport, which is similar to the river transport as well. We have suspension, which is when small loads are held up by the flow in the sea. We have flotation, which is when heavier loads are bounced or bumped along the seabed. As well as solution, which is similar to the solution in the marine erosion, where the chemical load is dissolved in the water. So you can see how a solution is basically about chemicals, like chemically dissolved and chemical load. And then we have traction, which is a step up of flotation, where the heaviest load is dragged or rolled along the seabed. As well as flotation, where it's the leaves or like very small load, like leaves and twigs that are carried on the surface of the water, which is basically similar to the suspension, but flotation is where the loads are floating on the water instead of being suspended in the water. Then we'll look into waves. So here are some key terms that you need to know for waves. So swash is a movement of material up the beach in the direction of the prevailing wind, and the opposite of that is backwash, where the movement of water back down the beach due to the effect of gravity. So here's what I mean. So let's say you have a beach right here, like beach, and then there you have water here. So let's say the wind comes from this side here, right? So the waves up the beach will move in this direction, right? Because it follows the wind, right? So this is a swash. And then backwash is where the movement of water back down into the beach or the ocean due to the effect of gravity. So it'll move actually straight down to the beach like this. And the wind comes in again, which pulls it up, which is swash. And backwash. Oops. And backwash. And backwash. So let me just label it clearly. So this is a swash, and this is a swash, and the other one going back into the ocean is a backwash, like so. And then we have constructive waves and destructive waves, which is shown right here. So constructive waves are waves with a long wavelength and a low height, and they help to build beaches by deposition. The opposite of that is a destructive waves, which are waves with a high height and short wavelength, and they would erode beach materials and cliffs, which is quite self-explanatory due to the constructive and destructive in the name. Then we have fetch. So here are some notes for the waves. So waves can affect coastal processes and coastal landforms. And for example, as I mentioned, constructive waves can help to build beaches, whereas destructive waves can not help, but they can erode beaches as they are high in energy. And as a key important note here, Wind can affect waves, for example, the prevailing wind, and sea breeze is a wind produced by temperature difference, and it is associated with an increase in wave and a bigger amplitude, right here. Then we have longshore drift, which is what I mentioned just now. So longshore drift is a movement of material along a beach by wave action. So just now in the previous slide, I talked about the swash and backwash. So this is longshore drift. And here's a more detailed diagram. So you have the prevailing wind coming in one direction. So this causes the waves to move up in the direction of the prevailing wind, which is called the swash. Then the waves will go back down into the ocean, which is called the backwash. So swash, backwash, and this continues. So as you can see, the general direction of the waves is to the right because it's going up to the direction, down, up in the direction, down. So it's moving to the right overall. And this is basically the direction of the longshore drift. And here are some notes. So longshore drift is one of the main ways in which material is transported along the coast, as it is quite obvious as if the waves generally move to the right, any load carried by the waves will move to the right. So that's how the loads move or transport along the coast. And longshore drift can cause significant beach erosion, as let's say you have all the materials like evenly spread around the beach. Let's say the sand's all around here. As longshore drift occurs, all the materials will be transported to the right, which means that the sand that's originally on the left will be transported to the right, which leaves this area here basically bare or like no sand. So this is a kind of coastal erosion or beach erosion. Then we have the features of coastal erosion. So here's a note. Coastal erosion leads to a lot of different features, of which includes caves, arches, stacks and stumps, cliffs, wave-cut platforms, headlands and bays, which we'll look into these later. So here's a diagram of cave, arches, stacks and stumps. So let me just zoom into the diagram. We have a crack here. So coastal erosion will first create a cave due to hydraulic action, which means that the crack basically explodes, which turns into a cave. And when the cave keeps eroding through the headland, it will form an arch right here, because basically it's a cave and the water just keeps eroding inwards until it goes all the way through, which forms this feature right here. And the arch will continue to be eroded until it cannot support itself. So this will basically just keeps eroding upwards until it cannot support itself under gravity, and it will collapse, which forms a stack right here, a stack. And the stack will then be attacked by the waves at its base, which over time will weaken the stack and it will collapse, forming a stump. So that's caves, arches, stacks and stumps. And then we have cliffs and wave-cut platform. So here we have a diagram here. So these are cliffs, as you can see, and I'm sure you know. And what's below it is a wave-cut platform. So the cliff is similar to this feature right here, where it's formed by hydraulic action and abrasion, where the seawater attacks the base of the cliff. And this causes a notch and overhang, which causes the cliff to collapse, as the cliff will be unable to support sand and it falls down. And this creates a wave-cut platform. And this is similar to how a waterfall is formed. So let me just draw a diagram right here. So let's say originally you have this huge chunk of cliff right here, right? Where let's say the seawater goes up to here. So there's a little part down here. There's a little part of the cliff right here. So over time, the cliff will be eroded because due to seawater, due to hydraulic action and abrasion, which will basically form this little notch and overhang. So the cliff will be eroded to form similar to this right here. Oops. Similar to this. And that's seawater level right here. Right here. Oops. Right. So this is basically the overhang, this part right here, because it's overhanging on basically nothing due to being eroded, and that's a notch. So over time, this part here will fall down, will collapse, which will eventually form this feature right here, which is the cliff and the wave-cut platform. So this is a wave cut platform and this is a cliff. And the seawater is still here. So as you can see here, the cliff is this part here. And the wave cut platform is this part over here. Then we have more features. So as I mentioned just now, the coastal erosion can lead to different features, amongst which is also headlands and bay, as you can see here. It's due to the alternating strips of less resistant and more resistant rocks. The waves will erode the less resistant rocks more than the more resistant rocks, right? Because the less resistant rocks are more prone to being eroded. This causes headlands at the more resistant rocks and bays at the less resistant rocks. So as you can see in this diagram here, we have bands of alternating hard rock and soft rock. So the water will erode these softer rocks more easily or faster. So these softer rocks form bay, and the more resistant rock, the harder rock, forms headland. So viewing from the top or from the side, you can see that it's basically a headland, bay, headland, bay, and this basically continues. So as you can see here, these are the bays right here, and these are the headlands right here. And moving on to more features of coastal deposition. So coastal deposition leads to a lot of different features, of which includes beaches, bars, coastal spit, and coastal sand dunes. So here we have beaches in the second part. We have beach refers to the accumulation of material deposited between long spring tides and the highest tide. And I'm sure you know what beaches are because they're quite common. Storm beaches are beaches where materials are pushed by the beach by spring tides and aided by storm waves. So here's just a diagram of beach, and I'm sure you're familiar with this. And then we have a more less familiar concept called bars and coastal spits. So a coastal bar is a coastal bar is a shallow sandbanks at the entrances to rivers and coastal estuaries. So here we have a diagram right here. We have land or beaches where longshore drift happens. So here we have longshore drift, right? As the prevailing wind comes in from one direction, the materials will get transported along the beach, which will cause this feature right here, which is called a spit or coastal spit, which is where it's a beach of sand or shingles linked at one end to the land, and it's found where the wave energy is reduced, allowing deposition to happen. So as the spit forms right here, it will form a bay, which is this area here. And over time, when longshore drift happens and the spit deposits more, it will cut off the bay right here, which will form a coastal bar, and the bay will form will be called a lagoon in this case. And here's a quick note: spits often become curved due to the wind because it comes in from one direction like this, so it will curve. And then we have coastal sand dunes. So coastal sand dunes are formed by strong onshore winds as they transport the sand easily. And dunes can be blown inland and can therefore threaten coastal farmland and villages. So for example, here's a beach right here where there's coastal wind from this direction, from the ocean to the beach, which will basically blow sand into inland right here, which will form different dunes. Like we have the embryo dunes, fall dunes, yellow dunes, grey dune, dune slag, and mature dunes, due to different processes. And you can see some more notes here. And then we'll move on to coral reefs, and here we look at the types of coral reefs. So here's a quick note before we go into the types. So coral reefs are an underwater ecosystem characterized by reef-building corals, and they are calcium carbonate structures. And they are found in sea temperatures above 18 degrees and 27 degrees Celsius, and they thrive between 22 to 25. So here's a quick important keynote that they thrive between this temperature. So if global warming were to happen and the sea water temperature rises, the coral reefs will actually die, which is what's happening right now. And they require shallow water because they need sunlight, and they need water with high salinity and clean water. However, coral reefs face a lot of pressures due to destruction by fishing industry as they use dynamite to flush out fish and oil spills from the oil company, or like any other companies that dump oil in the water. So here we have the three main types of coral reefs that we'll look into in this syllabus. So this includes fringing reefs, barrier reefs, and atoll reefs right here. And then we will move on to mangroves. So mangroves are salt-tolerant forests of trees and shrubs that grow in coastal zones of tropical areas. And they have adapted to live in these regions where it's salty and it's near the coast. And they can happen, or they can be found between high and low tide watermarks, and they have aerial roots, which means that their roots are above the ground. So here's a diagram of mangroves. As you can see, the roots are aerial, which means that they're above the ground, which provides them more stability because they live near coast area where there are waves. So these trees or like these mangroves need to be very stable on the ground. And mangroves are mostly found in tropical coastline, as they prefer tropical or subtropical regions above 5 degrees Celsius. And here's a quick statistics to note that about 42% of the world's mangroves are found in Asia, where it's mostly tropical or subtropical regions. So here's importance of mangroves. So mangroves provide large quantities of food, fuel, and building materials. And building materials. And they also help to protect the coastline by absorbing the force of hurricanes and storms. So they serve as a buffer for storms. So what this means is that, let's say you have this bunch of houses over here, and then you have mangroves between the houses and the ocean. So these are mangroves. And then you have ocean right here, like this whole chunk of beach and ocean. So when the waves come in, when huge wave comes in, if the mangroves weren't there, the waves would just crush a house, right? But if the mangroves were there, the mangroves will actually absorb the energy from the waves, which will reduce the energy of the waves, which means that by the time the waves get to the house, it'll be just a very small wave or no wave at all. Then here we have coastal management. So there are basically two ways of managing or protecting the coastline, and that is through soft engineering and through hard engineering. So soft engineering structures try to work with nature, as the name suggests. It's a soft approach to coastal management, and they are often cheaper than hard engineering structures. And examples of this include offshore reefs, beach nourishment or beach replenishment, which means to replenish the beach, and manage retreat. Whereas hard engineering basically tries to build structures to protect the coastal area, and this includes seawall, groins, rock armor, and revetments. So here we have this seawall right here, this curved seawall, where it's basically built to protect the coastline, and we have rock armor right here. And here we have a case study, which is the opportunities presented by an area or areas of coastline, the associated hazards and their management, and we'll look into the Holderness Coastline. So here's a quick note of the Holderness Coastline. It's a coast located on the east coast of England, and it stretches across 61 kilometers from Flamborough to Spurn Point, where it meets River Humber in the south. So as you can see here, this map right here. And the Holderness Coastline is eroding at a fast average annual rate of 2 meters per year, which is significantly higher than the average UK rate of 0.43 meters per year. So here are opportunities to live near the Holderness Coastline. There's a road, which is this specific road right here, running through Mapleton, which is a small village by the coast of the Holderness Coastline, which links town along the coastline. And this road is protected by engineering methods, for example soft or hard engineering methods, which we looked into the previous slide. And here's some statistics. So 4.5% of the local population is employed in agriculture, which provides food for the local. And the coastline attracts millions of tourists each year, as do all coastlines or beaches do, which basically contributes significantly to the local economy, as there are a range of activities you can do there, for example bird watching and walking along the coast. Then here we have the reasons for the rapid rate of erosion in the Holderness Coastline. So the Holderness Coast is made out of crustacean chalk, And the cliffs are also made from less resistant boulder clay, which means they are easily eroded. And if you remember just now, the headlands and bays, they are basically bands of less resistant and more resistant rock. But in this case, it's mostly less resistant rock or boulder clay. And the coast is exposed to wind from the northeast, which means that there's a fetch of around 500 to 800 kilometer, which basically means the wind travels this distance before arriving at the coast. And with the currents from the Atlantic circulate into the North Sea, this means there are strong prevailing winds which create strong longshore drift that will create very strong transfer of materials from one end to the other, which will move material south. And this leads to the loss of valuable personal property and recreational areas. As let's say if we have a beach right here, let's say you have a beach, and let's say if the wind comes from this side, let's say if the wind comes from just an example, the wind comes from this side right here, and let's say if we have houses down here, so it's a really badly drawn house, and if the wind were to come from here and go back, basically prevailing wind, the direction of the longshore drift will go from left to right, which means that this part here will be eroded, and at one point the land near the house will get eroded and the house might collapse, which means this means that there will be a loss of valuable personal property. And lastly, we'll look at the management of the Holderness Coastline. So hard engineering methods and soft engineering methods have been employed, as I mentioned. So the hard engineering methods employed include groins and rock groins, which are very similar. So for the groins, as the coastline is eroding at a fast annual rate, groins are built at the north of the coastline to trap sediment carried by longshore drift, and this keeps the beach in place. And the same for rock groins. 2 rock groins are built at Mapleton after a campaign was organized by the residents, and it cost them around £2 million to protect the coastline, which arguably is justified because this basically protects the coastline and preventing the loss of valuable personal property. And here's just a photo of the rock armor groin in the Holderness coast at Mapleton. And another soft engineering method is beach nourishment or beach replenishment, where it's happening at the north of the coastline, which adds sediment to the beach, but this is prone to a large storm. So more detail or more explanation of what this beach nourishment is that imagine you have a beach which is constantly eroded by wind due to the prevailing wind taken away from the material, so longshore drift happens and the material gets moved along the beach. So you have really bad sand over here, like very little sand, and a lot of sand here. So what beach nourishment is that the people will add materials to this side right here because there's basically barely any sand, and they will nourish the sand, basically add more sand here so that it's more even. But as I mentioned here, it's prone to a large storm because if a storm were to come, it will basically wash away the materials here because they are just newly added, which means they are prone to large storm. Yeah, and that's it for this video. And that's it for this video for IGCSE Geography for the video of coast, and I hope you enjoyed this video. And if you need any more learning resources or any teaching resources, you can check out my website in the description, or you can type it out in your browser at www.MakesItEasy.com. And I hope you enjoyed this video on coast, and I'll see you all in the next video. Here's to learning made easy.